Hi, this is Team16 and this is Yichao and Tianyu. We are presenting our final project. Driven by the enthusiasm in the recently boosting development of the autonomous electric vehicles, we carried our final project to build these small-size autonomous vehicles. The objective of this design mostly comes from the fundamental features of a real-size EV, such as obstacle avoidance, recognition of the traffic signals, path reconstruction, and etc. To meet those expectations, we have defined our major functions as below. And here in the following videos, we will demonstrate how we meet each of those functions.
When it comes to the components we use in our project, the first one is the RGB color sensor, KCS3200. It will send back the RGB readings, and our color recognition part is based on the reading data. Then we use 3 ultrasonic distance sensors to detect the distance between the wall and the small vehicle in 3 different directions. The motor control module will help us to control those 2 motors more easily. With the motor control module, the 2 motors can easily perform linear forward, linear backward, and turning motions. The last module is the Bluetooth module, HC05. It helps us to realize the wireless communication between PC and the small vehicle. Then it's our recording of the small vehicle testing in a U-shaped path. We can see from the video, the small vehicle prefers the direction with bigger space in the map. And it will also stop on the black part in the map due to the color recognition function. When it comes to our path reconstruction part, we write some Python code to save the data sending back from the wireless communication. The first package we use is the PySerial to save those data, and then we use matplotlib to draw the path figure.
So after the success in the U-shaped map, we then increase the complexity of the map and put more obstacles. But then unfortunately, we have observed frequent collisions. So this is due to the existence of the blind spots. Since we have placed the 3 distance sensors in the following arrangement, inherently there exist 2 big blind spots as shown in the red square. Any obstacles in this area can cause collisions potentially. To improve our algorithm, we then propose this alternative design. So here we have changed the orientation of the 2 side distance sensors to 45 degrees from the forward sensor. In this way, the space of the blind spots are sharply reduced. But also there are some drawbacks. In this orientation, we are very hard to control the turning angles of this vehicle. Therefore, as we cannot guarantee the turning angle to be 90 degrees, we cannot do the path reconstruction. The alternative design is then tested with random obstacles on a platform. As proven easily, with less blind spots, and the system will be more robust handling those obstacles. So lastly, we put our alternative design in this S-shaped map. So this map has been very challenging for the old design when there is like a big blind spots. But now with this improvement on the blind spots, the alternative design can easily navigate itself from the beginning to the destination. So in summary, when we're looking backward, we have learned that uncertainties can come from multiple sources, not only the blind spots in the design, but maybe also the inconsistent voltage supply or even the frictions on the substrate. And looking forward, we expect the effectiveness of the algorithm to increase if we can have even more sensors on board. Thank you.